Bismillahirrahmanirrahim. Welcome back. Today we have another task of implementation of adders and subtractors in Proteus. Let us first discuss what are adders and subtractors. An adder is a digital circuit that performs addition of numbers. So in hardware, in hardware we use some digital logics, digital logic gates in order to perform different calculations. And for addition, we use circuits which are called adders. So in adders, we have a half adder and full adder. So what are half adders? The half adder adds two binary digits called as augend and addend and produces two outputs as sum and carry. So adders are the circuits which adds two binary digits. So the digits, one of the input will be augend and the other will be addend, and the outputs produced are one will be sum and the other will be carry. Let us see from its circuit. The one of the input is augend and the other is addend, and one of the output is sum and the other is carry. So by using these two logic gates, we have performed half addition. And we can also use NAND gate implementation in order to perform the addition operation. The inputs and outputs will be the same. Same is the case with half subtractor. Half subtractor is used for subtracting one single bit binary digit from another single bit binary digit. So one bit one bit binary digit will be subtracted from one bit binary digit, and we will have subtraction and a carry. Now if we see from the table of half adder, we have we have two one bit inputs, a sum and a carry. So let us see its implementation in Proteus. We have we can see from the table that when we give 0 0, we get sum and carry both 0. So this is a default condition case where we get both 0 and the sum and carry both are 0. Let us give it the inputs as 0 1 0 1, then we get the sum as 1 and carry as 0, sum 1 and carry 0. If we give both inputs as 1, then the sum is 0 and the carry is 1, sum is 0 and carry is 1. Same is the case with the NAND implementation. 0 0 gives 0 0 in the output, 1 1 gives 0 1 in the output, 0 1 gives 1 0 in the output. So this is the implementation of an adder in Proteus. Let us now implement the subtractor in Proteus and see whether it conforms the table we are given for the half subtractor or not. So the inputs are same. We get a difference and a borrow. So let us see that if we give both inputs 0 0, it gives us 0 0 in the output. Same is the case with the NAND implementation. If we give it a 0 1, so we get 1 as difference and 1 as borrow. 0 1, 1 as difference and 1 as borrow. So if we give it a 1 0, then we get a difference of 1 and a 0 in the borrow. and if we give it 1 1, we get 0 0 in the difference and borrow. 1 1 is, we get 0 0 as difference and borrow. So this was implementation of half adder and half subtractor in the Proteus, and we will now go to full adder and full subtractor. So full adder adds three 1-bit numbers. So there will be 1-bit numbers A, B, and C. Let us see what are they. Where two can be referred as operands. So the addition will be between two inputs, and one can be referred as a bit carried in. That will be a carry in. Let us we will see in the future what carry in will look like, and produces 2-bit output, and these can be referred as output carry and sum. The one will be output carry and the other will be sum. So what is a full adder? The difference between a half adder and a full adder is that the full adder has 3 inputs and 2 outputs. A full adder has 3 inputs and 2 outputs, where half adder has 2 inputs and 2 outputs. We have saw in the previous example for adders and subtractor that the adders have 2 inputs, A and B, and the output will be a sum and a carry. That is the case with the half adder. Now with a full adder, we have 3 inputs and 2 outputs. Among those 3 inputs, we say that the operation is between two inputs that are called as operands, and one will be carry in. Now the subtractor, full subtractor is the same, but the logic circuit which is used for subtracting 3 single bit binary digit is known as full subtractor. We will see how we confirm the results from this table, that 3 inputs are there, and two are basically the operands and one is a carry in. Okay, we get a sum in the output and a carry out in the output. So for 0 0 in the input, if the carry in is 0, we get 0 in sum and 0 in carry out. If the carry in is 1, we get sum as 1 and carry out as 0. Now we will see different cases in Proteus. These are the sets, and we will see how a full adder works in Proteus, and how the carry in controls the operation between the two inputs and and displays the output and carry out. So let us see the implementation of a full adder, and we have discussed the table of a full adder, and we will see now that if both the inputs are 0 and the carry in is 0 and 1, how it controls its output. Let us see. If the carry in is 0, we get sum and carry out as 0. If the carry is 1, then we get a sum as high. We get some input, sum as output, and carry out as low. Same is the case with the obviously NAND implementation. If now if the set of input is 0 1, how it controls it? If it is 0 1, then if the carry is 0, then we get sum as high and carry as 0 as low. But if the carry is high, carry in is high, then we get sum as 0 and carry out as high. Let us see. If the carry in is 0, then we get sum, and if the carry is high, then we get carry out as high. Same is the case with the 1 1. If it is 1 1, if the carry in is 0, then we get a carry out in the output, and if the carry in is high, then we get sum and carry out as high. So we have confirmed the operation of full adder in Proteus. Now let us discuss the operation of a full subtractor. So for the case of 0 0, if borrow in is 0, then we get both difference and borrow out as 0. That is given in the default case. If we give the borrow in 0, then we get difference and borrow out as high. That is shown in here. If we consider an example of 1 1 and see the borrow in, how it controls it, then if these both inputs are high and borrow in is 0, then we see that we get difference as 0 and borrow out as 0. If we give borrow in 1, then both of the difference and borrow out are high. That is shown in the output. So we have successfully implemented the tables of half adder and subtractor and full adder and subtractor in Proteus, and we have also discussed the operation of these adders and subtractor, full adder and subtractor, and half adder and subtractor. So that is it for today. See you next time. Allah Hafiz.